Hey, welcome! Today we're going on a pretty epic journey to the single most important object in our sky. I'm talking, of course, about the star that makes all life on Earth possible, the Sun.
You know, we see it every single day, but have you ever really stopped to think about what's going on in there? What's powering that colossal furnace? And what would we find if we could somehow travel right through it?
Well, that's exactly what we're going to do today. In this explainer, we are taking a virtual trip, layer by layer, straight into the heart of our home star. So let's get started.
First things first, let's just try to wrap our heads around the sheer scale of this thing. The Sun is so unbelievably massive that it makes up 99.86% of all the stuff in our entire solar system. Yep, you heard that right. Everything else, all the planets, moons, asteroids, all of it is just a tiny little speck left over. It really is the center of everything. Okay, so our journey begins on the outside. But here's the thing, the outside of the Sun isn't some solid surface. Nope, it's this huge layered atmosphere made of something called plasma, which is basically a superheated gas.
As we head in, we're going to pass through three main zones. First up is the photosphere, then we'll hit the chromosphere, and after that, the very mysterious corona.
Our first stop is the photosphere. Now this is the part of the Sun that we actually see from Earth. It's what looks like the surface. It's not solid ground, of course, but it's this churning layer of hot plasma. And it's where all the sunlight that warms our planet finally gets released and starts its journey to us.
And right away, things get, well, kind of weird. As we move away from this super hot surface, you'd think it would get cooler, right? Like walking away from a bonfire. But with the Sun, the complete opposite happens. Its outermost atmosphere, the corona, is a mind-boggling 1 to 2 million Kelvin. Why it's so much hotter than the surface is seriously one of the biggest puzzles in astronomy.
All right, we've made it through the atmosphere. Now for the fun part. We're going to plunge deep into the Sun's interior, where the conditions get, well, truly extreme.
Our first stop inside is the convective zone. The best way to picture this layer is to think of a giant boiling pot of water. You've got these huge columns of hot plasma rising up, cooling off as they get near the top, and then sinking back down. This creates these enormous circular currents that are constantly carrying the Sun's energy outward.
Okay, deeper we go, into the radiative zone. And in here, things get incredibly dense. So dense that a particle of light, called a photon, can't just travel in a straight line. Instead, it gets absorbed and shot out again by atoms over and over, just bouncing around like a pinball. It's basically a cosmic pinball machine, and a single photon can get trapped in there for, well, a very, very long time.
We've passed through the outer layers and that super dense interior, and now we've arrived. This is our final destination, the core. This is the engine room, the power plant, where every last bit of the Sun's incredible energy is actually created.
The conditions in here are they're almost impossible to imagine. The temperature skyrockets to 15.7 million Kelvin. The pressure is absolutely crushing. This is a place of truly cosmic extremes.
And about that pressure, the matter here is packed so tightly that it's 150 times denser than water. To put that in perspective, imagine trying to swim through something 150 times thicker than water. It's this incredible pressure and heat that sets the stage for the Sun's ultimate magic trick.
See, all this heat and pressure creates the perfect storm for nuclear fusion. Down here, hydrogen atoms are being smashed together with so much force that they literally fuse into helium. And when that happens, a tiny bit of their mass is converted into a colossal amount of energy. That's it. That's the process that has powered our Sun for over 4.5 billion years. But here's a fact that might actually blow your mind. For all that incredible fusion going on, the amount of energy generated per cubic meter is surprisingly low. In fact, scientists have figured out that the power density in the Sun's core is about the same as a garden compost pile. The Sun's real power comes from its absolutely gigantic size, not from being some super efficient engine.
So we've reached the center, but our story is not over. Not even close. How does all that energy created in the core actually make its way out to us? Well, this final leg of the journey might just be the most incredible part of the whole story. Remember that cosmic pinball machine, the radiative zone? Well, get this. A single photon born in the core can take, on average, a staggering 170,000 years just to bounce its way to the surface. I mean, think about that.
That journey is just unimaginably long and chaotic.
And here is the real kicker. After that epic 170,000-year struggle to escape the sun's interior, that very same photon zips across millions of miles of empty space to reach us here on Earth in just over 8 minutes. It's such a wild contrast, and it really shows you just how incredibly dense the sun truly is.
So our journey is complete. We've seen that the sun is built in layers, kind of like an onion. We've traveled from its bizarrely hot atmosphere all the way down to its dense interior. We've witnessed the nuclear furnace of the core, and we've followed the ancient 170,000-year-long path that a single particle of light takes just to reach the surface. And that brings us to a final, pretty profound thought. That 170,000-year journey means that the sunlight hitting your face right now was actually created in the sun's core long, long before the first modern humans ever walked the Earth. It's this incredible, humbling connection to our star's deep past. The sun has taught us so much, but with huge mysteries still out there, you just have to wonder, what secrets is it going to reveal to us next?